How elegantly does quantum mechanics explain the periodic table? Imagine a world where the arrangement of every element is written in the language of tiny particles and their energies. That's what quantum mechanics helps us understand about the periodic table. It's like discovering the secret code behind how elements are organized. The periodic table was first made by Dmitri Mendeleev in 1869, based on chemical properties and atomic weights. But the real reason elements line up the way they do comes from how electrons behave inside atoms, which quantum mechanics explains perfectly. Quantum mechanics describes electrons as existing in regions called orbitals around the nucleus. These orbitals are like clouds where electrons are most likely to be found. Each electron has four quantum numbers that tell us its energy, shape, orientation, and spin. The Pauli exclusion principle, a key rule from quantum theory, says no two electrons can have the same set of these numbers. This rule makes electrons fill available orbitals in a specific order, creating unique electron configurations for each element. These configurations determine how elements react chemically and where they sit in the periodic table. Elements in the same group share similar valences electron arrangements, which explains their similar behaviors. The rows or periods on the table correspond to filling successive energy levels or shells of electrons. So, the table is a large map of how electrons occupy different quantum states. In 1913, Henry Moseley discovered that the number of protons in an atom, called the atomic number, is what truly defines an element. This discovery aligned perfectly with quantum mechanics, which shows that the number of protons influences the electron configuration. Quantum theory also explains the placement of transition metals and the lanthanide and actinide series, which involve filling d and f orbitals with electrons. The energy differences and shapes of these orbitals account for their unique properties. Quantum mechanics allows scientists to predict properties like how easily an atom loses electrons or how big it is, with high accuracy. This has led to the development of quantum chemistry, which helps us understand molecules and chemical reactions. The evolution of the periodic table from a chemical tool to a physical law shows how atomic theory and quantum mechanics have advanced human knowledge. In essence, quantum mechanics explains the periodic table with remarkable clarity by showing how electrons occupy specific energy levels and orbitals around the nucleus. This arrangement determines an element's properties and why elements repeat periodically. It connects the structure of matter directly to the principles of energy and atomic behavior, marking a major step in scientific discovery.